Hi there, in this video I will talk about filling up the NA values. So in the last video you must have seen how you can identify and drop the null values. That's one of the ways to treat your null values or the missing values. But another way to treat the null values or the missing values is to fill them up. And here in this video I will show you a couple of different methods by which you can fill the null values. So first of all, let's import our libraries, which is Pandas as PD, and we will import another library which is NumPy as NP, because I will just create a custom series which will having the NaN, not a number value, which we can create it by using np.nan. So I'll just execute that, and I will just create the object which is null values is equal by creating pd.series, and here I can specify some dummy numbers which can use this parenthesis and then these brackets, and say let's say 1 comma np.nan comma 2 comma np.nan 3 4 and another missing value, and let's say 8 for example, and let's go ahead and execute this. Alright, now it is fine. So if you just print the values, you will see that 1 NaN, which is not a number, 2 3 NaN, then not a null. So you have a couple of different methods within Python to take care of. So the methods like forward fill and backfill. So what it does is it takes the first value in case of forward fill, and based on what you have specified, it will going to fill up that value. So here in this case 1 is here, np.n will have 1. Now it has seen second value, then it will fill up this value. In case of backward fill, it will see the last value and fill up the values above which are null. So let's see these things in action. Alright, so I will write null values dot fill NA. I just press the tab, and it has some properties, and the method we are looking at here is this. Right now the method is none, but if I show you the values for methods, so you have bfill, ffill, pad, none. The most important are bfill and ffill, which I will just show you. Pad is I think pretty much similar to ffill, and backfill is bfill. So let's go ahead and method is equals to ffill and press enter, and now you can see for that index 1, earlier it was NaN and now it has 1. So in case of forward fill, as I explained it earlier, it is taking up the values which is right above this null value and filling up that particular piece. Similarly, in case of 2, the 2 is coming over here for third index number, which was earlier null. When in case of this fifth index number, the value is 4, and right after that 2 values are null, but now you can see the 6 and 7 values are having 4 and 4. Now let's replicate it or reverse it using bfill, and now you can see it's completely opposite. Alright, one other thing is when you are using fill NA, let's say you don't need any value, but you just want to replicate the missing values with let's say 0. So you can just simply specify 0, and now in this case you will see that you are getting 0 for all those values. So this way you can replicate 0 with the help of, and that will help you when you are doing some operations which require that, especially in machine learning, which requires that there should not be any missing values. So it's better to just replicate it with the 0 and don't have any missing values. Another method that you can use is, and it's pretty interesting because I think in many cases it gets used, using the average value np.mean. Alright, I just need to specify, that's why it is giving a little bit odd output, just the function mean. And I need to specify null underscore values. Now you can see the mean value 3.6 is replicated all over the place. So this way you have np.mean, and there are other methods as well within the np. Say for example sum and min, max, and other things by which you can replicate the null values. That ideally that is based on how your data set is and your research problem. Now let's use another parameter. So far we have been using method parameters ffill, and now I'm using limit parameter and specifying 1. So what it does is, after index 0 there was a null value which was the first value, and it will properly pop up. But in case of index number 4 you had 2 missing values. So in that case, or maybe it was I think 5, because I can see 3.6 coming 2 times. So for index number 5 you have, after that you had 2 missing values, so it will just fill up the value for 6th one, but it will not fill the value for 7th one. And that's what limit means, that just add or just fill the consecutive value or the next appearing null value. So let's go ahead and see it in action. Alright, something I have I guess silly mistake. Who will write fill an A? Okay. Now you can see after 5 you have 6 as 4, but for the 7th value there is an AN, because we have specified limit is equals to 1. That means just fill the very next value, not the other missing values. The next and very interesting method to fill the null values is interpolate. Null values dot, if I write interpolate and just execute this, you will see some interesting patterns, like for 1, 1.5, 2, 2.5, 3, 4, 5.33, 6.66. So interpolate is basically a statistical term, and especially useful in such cases where you have the data, let's say specifically in case of distributed time series, the data is distributed over time period, and for a couple of time periods the data is missing. So what it does is it looks at the internal trend of the data about how the values have been distributed, what is the interval, and based on that trend and interval it basically fills up the value. So what it sees over here is that there is first value, there is value 1 for index 0, for index 1 there is null, and for index 2 there is 2. So between 1 and 2 probably you may be having 1.5 based on the trend. Similarly between 2 and 3, 2.5. Now between 4 and 8 you have 2 null values, so that's why it has changed the equation a little bit and saying 5.33 and 6.667, and then filling up the missing values. So this is pretty interesting, and it follows the interval or the trend of your series. Say for example, if you have, let's say, so if I just show you by creating another series, interpolate underscore series is equals to pd dot series, and write 1 comma np dot an comma, let's say 5 comma np dot nan comma 9 comma np dot nan comma 13. So you can see that I have the interval of 4 over here. So between 1 and 5 4 values, 5 and 9 again 4 values. So that way I have just created a simple series which is following up some sort of an interval, proper interval, and I'll just execute that, and I will write interpolate underscore series dot interpolate and execute that, and you will see that 1, and after that it has written 3 and then 5 and then 7 and then 9 and then 11 and 13. So this way it has identified a trend that after between 1 and 3 there is an interval which indicates that probably it is 2 steps or a regular interval like arithmetic progression it is following, and that way it has populated 1 after 3 and 5 and then 7 and then 9 and 11. So that way you can see how it can help you to really populate a bit of a realistic series or a realistic number based on the trend your data is following. So that's about it, and you can see its different method, how the limit direction, the downcast method. As you can see, it is linear. I think there can be geometric method, if I'm not wrong, or a couple of others, but you can explore. And then you have limit and in place. So this way you can fill up your any values and get the desired output. So I'll meet you in the new video, the new topic.